Here we have a Olympiad math problem. In the given equation, we have to solve for x. Okay, let me consider some stuff on product of two binomials. Okay, now let me consider the product of two binomials a positive b and a negative b. So here we have two binomials. One is a positive b and other one is a negative b. And in both the binomials, we have the same terms a and b. But in the first binomial, we have positive sign between a and b. The second one, we have a negative sign between a and b. So whenever I multiply two binomials in this form, always it will result the product a square negative b square. So this is the product. I mean, the difference of the two squares, a square negative b square, is the product of these two binomials. Okay, now let me consider another two binomials in the same form. That is 4 positive square root of 15 times 4 negative square root of 15. Okay, now the product of these two binomials is in the same form, a positive b times a negative b. At the place of a, we have 4. At the place of b, we have square root of 15. So on the right side, instead of a square, we have to write 4 square, and instead of b square, we have to write square root of 15, the whole square. And here the square and square root can be cancelled out, and we get 16 negative, and we have 15 over here. So we get 4 positive square root of 15 times 4 negative square root of 15 on the left side. Okay, again, let me write the same thing. 4 positive square root of 15 times 4 negative square root of 15. On the right side, when I simplify this one, I'm just getting 1. Okay, now in this equation, I'm going to solve for this 4 negative square root of 15. So for that, I have to get rid of this 4 positive square root of 15. So let me divide both sides of this equation by 4 positive square root of 15. Then this one will cancel out. I'm getting 4 negative square root of 15 equals to 1 over 4 positive square root of 15. Okay, now I have solved for 4 negative square root of 15. So that is equal to 1 over 4 positive square root of 15. So the given equation, so for this 4 negative square root of 15, we can plug in this 1 over 4 positive square root of 15. Okay, let me continue with the given equation. So 4 positive square root of 15 over to the x power positive. And for this 4 negative square root of 15 over here, we can plug in 1 over 4 positive square root of 15 whole to the x power equals to 62. Okay, we have 4 positive square root of 15 whole to the x power positive, and here we have the exponent x for the fraction over here. So whenever we have a common exponent for a fraction, I mean the common exponent for the numerator and denominator, so the exponent can be taken separately for numerator and separately for denominator. Then I'm getting 1 to the x power divided by 4 positive square root of 15 whole to the x power equals to 62. 4 positive square root of 15 whole to the x power positive. Here we have 1 to the x power, that is the base is 1 and the exponent is x. So whatever exponent we take for the base 1, always the result, the value of this power equals to 1. Because when 1 is multiplied by itself for any number of times, it will result just 1. So 1 to the x power will result just 1, and divided by 4 positive square root of 15 whole to the x power equals to 62. So here we have 4 positive square root of 15 whole to the x power, and also we have the same stuff over here. Okay, to make the solving process easier, also we can assign a new variable for this one. So that is, I'm going to assign a new variable y for 4 positive square root of 15 whole to the x power. So then this equation will become what? So this stuff can be replaced by y. So y positive 1 over, and this one also can be replaced by y. So y positive 1 over y equals to 62. Okay, now we have to solve for y in this equation. So once we solve for y in this equation, then y can be replaced by this stuff, and then we can solve for x. Okay, now let me continue on the next page. This is the equation we have had on the previous page. Okay, now let's simplify this stuff over here. That is y positive 1 over y. Okay, now let's assume this is integer and it's a fraction. So whenever we want to do addition or subtraction between an integer and a fraction, so what we have to do is we have to multiply the integer part by the denominator of the fraction. So once we are done with this multiplication, we can take this denominator y as a common denominator. Okay, when I multiply this integer part y by this denominator y, that is y times y is y square, and we have positive sign 1. Now we can take this y as a common denominator, so equals to 62. Okay, now let me multiply both sides by y. So this y will cancel out. I'm getting y square positive 1 equals to 62 times y is 62y. Okay, now let me subtract 62y from both sides. When I do so, so this positive 62y, negative 62y will cancel out. I'm getting y square negative 62y positive 1 equals to 0. Okay, now this is a quadratic equation in standard form. I don't think we can solve this factoring. We can solve this quadratic equation by factoring. So we have to use a quadratic formula to solve this quadratic equation. Okay, for that, this quadratic equation has to be compared with a y square positive by positive c equals to 0. When I do such comparison, I'm getting a equals to 1. So a is the quotient of y square. Here the quotient of y square is 1, and b is equal to negative 62, and c is equal to 1. Okay, now let me write the quadratic formula we have over here. That is y equals to negative b, positive or negative, square root of b square negative 4ac over 2a. Okay, now what I need to do is I have to plug in the values for a, b, c. Negative, this negative comes in the formula itself, and the value of b is negative 62, positive or negative square root of b square means negative 62, the whole square, negative 4 times the value of a is 1, the value of c is also 1, over 2 times the value of a is 1. Okay, y equals to negative times negative will become positive, 62, positive or negative square root of. So now let's evaluate the value of negative 62 to the whole square. Since we have an even exponent, the negatives and inside the parenthesis will become positive. So whenever we have even exponent for negative sign, it will become positive. So now we have to get the value of 62 square. The value of 62 square is 3,840. 4 negative 4 times 1 is 4. Again 4 times 1 is 4. So we just get 4 over here over 2. So y equals to 62 positive or negative square root of 3,840 over 2. Okay, now we have to simplify this 3,840, square root of 3,840. Okay, now let's evaluate this one separately. Okay, so for that, first we have to resolve this 3,840 into prime factors. Okay, let me use the L division for that. 3,840. So it ends up with the digit 0. So it's an even number. We can divide it by 2. When I divide it by 2, I'm getting 1,920. Again, the last digit over here is 0. So it's an even number. So we can divide it by 2. I'm getting 960. Again, it can be divided by 2. I'm getting 480. Again, I divide it by 2. I'm getting 240. Again, I divide it by 2. I'm getting 120. Again, I divide it by 2. I'm getting 60. Again, I divide it by 2. I'm getting 30. Again, I divide it by 2. I'm just getting 15. Okay, so when 15 is not divisible by 2, it's an odd number. So we can divide it by 3. Then I'm getting 5. So 5 is a prime number. So we can stop. So now square root of 3,840 can be written as, let me finish writing. So how many 2s are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 2s. Okay, let me write it over here. 2 times, 2 times, 2 times, 2 times, 2 times, 2 times. Let me count 2 times, 2 times, 3 times, 5. Let me count 2, 4, 6, 8. There are 8 2s. Okay, for every 2 same numbers multiplied inside the square root, one number will come out. For these 2 2s, 1 2 will come out, and for these 2 2s, 1 2 will come out, and the same thing. So we have 4 2s out of the square root. 2 times, 2 times, 2 times 2. Square root of 3 times 5 is just 15. And finally, it is simplified to, and when I multiply 4 2s, I'm getting 16. 16 times square root of 15. So now I'm getting y equals to 62 positive or negative, and the simplification of this one is 16 square root of 15 over 2. Okay, now let me continue on the next page. This is the last step we have add on the previous page, and here 2 is a common divisor for this 62 and this 16 times square root of 15. So this divisor 2 can be taken separately for this and this. When I do so, I'm getting y equals to 62 over 2 positive or negative 16 times square root of 15 over 2. So here 2 goes into 2, 1 times 2 goes into 6 thrice, and 2 goes into 2 1 times, and 2 goes into 1 times, 2 goes into 16 8 times. So I'm getting y equals to 31 positive or negative 8 times square root of 15. Okay, now we can write this one as a y equals to 31 positive 8 times square root of 15, or y equals to 31 negative 8 times square root of 15. Okay, so actually y is a variable taken by us. So originally we have assigned y for 4 positive square root of 15 whole to the x power. Only for this stuff to make the solving process easier, so we just assumed y for this one only. So now we can replace y by the original stuff, that is 4 positive square root of 15 whole to the x power. On the right side we have 31 positive 8 times square root of 15, or So the same thing we can do over here. This y can be replaced by 4 positive square root of 15 whole to the x power equals to 31 negative 8 times square root of 15. Okay, now here we have two equations. Now in these two equations, we have to solve for x. Okay, let me take the first equation over here. I'm going to solve for x in the first equation. So that is 4 positive square root of 15 whole to the x power equals to 31 positive 8 times square root of 15. Okay, so 4 positive square root of 15 whole to the x power equals to this 31 can be written as 16 positive 15 positive 8 times square root of 15. I just split up this 31 into 2 parts, that is 16 positive 15. There is a reason behind it. Okay, so 4 positive square root of 15 whole to the x power, and I'm writing this 16 at first, then I'm writing this positive 8 times square root of 15, and then I'm writing this positive 15 at last. Okay, now 4 positive square root of 15 whole to the x power equals to this 16 can be written as 4 square, and this 8 can be written as 2 times 4 times 2 times 4, and then we can write this square root of 15 over here positive. Instead of writing just 15, I'm going to take a square root of 15 square root for this 15. So to balance this square root, I just square this one, because even if I simplify this one, what I get, because the square root and square root cancel, I'm getting 15. So why should I take square root for this 15 and I take square? There is a reason. Okay, and also here I have written this 8 as 2 times 4. Okay, now I've written this 16 as 4 square. So I've made some changes in the expression over here, but it is equal to the original stuff. The reason is I just want to get the expression that is in the form a square positive 2 times a times b positive b square. So let's compare the trinomial over here with a square positive 2 times a times b positive b square. At the place of a we have 4, at the place of b I have square root of 15. So whenever I have a trinomial in this form, a square positive 2ab positive b square, so what can I write for this one? I can write a positive b the whole square. It's one of the basic identities of algebra. Okay, now let me continue. 4 positive square root of 15 the whole square, sorry, whole to the x power equals to, so when we have the trinomial a square positive 2ab positive b square, instead of that we can write the square of the binomial a positive b, that is a positive b the whole square. Then what can I write for this one? So it's very simple. At the place of a, we have 4. At the place of b, we have square root of 15. So we can write 4 positive square root of 15 the whole square. Okay, now, so here the stuff on the left side, the stuff on the right side are equal. So we have the same base on both sides, 4 positive square root of 15, 4 positive square root of 15. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. So when I equate the exponents, I'm getting x equals to 2. So now I've solved for x in the first equation over here. Okay, now I have to solve the second equation over here. Okay, now let me do this on the next page. This is the second equation we have had on the previous page. Okay, so let me write 4 positive square root of 15 whole to the x power. So now I'm going to do the same thing what I've done for the first equation. That is, I'm going to split up this 31 into 2 parts. That is 16 positive 15 negative 8 times square root of 15. So 4 positive square root of 15 whole to the x power equals to the 16 can be written at first, and then we can write this negative 8 times square root of 15 positive 15. So 4 positive square root of 15 whole to the x power equals to this 16 can be written as 4 square negative 2 times. I mean, we can write this 8 as 2 times 4. Further, we have to write this square root of 15 positive, and I'm taking the square root for this 15. So I'm taking square root for this 15. To balance the square root, I just square it. So even if I simplify this expression, it is equal to the stuff we have over here. Now the trinomial we have over here is in the form of a square negative 2 times a times b positive b square. Okay, whenever we have a trinomial in this form, a square negative 2ab positive b square, it can be written as a negative b the whole square. It is one of the identities in algebra. So now comparing this and this, so I'm getting 4 at the place of a, and also I'm getting square root of 15 at the place of b. So for a negative b the whole square, what can we write? So we just have to write 4 at the place of a over here, negative. At the place of b, we have to write square root of 15, then we have to write whole square. On the left side, we can take this stuff as it is, that is 4 positive square root of 15 whole to the x power. Okay, already we know that this 4 negative square root of 15 equals to what? Already we have solved for this 4 negative square root of 15 earlier in this problem. So that is 4 negative square root of 15 equals to 1 over 4 positive square root of 15. So now this 4 negative square root of 15 can be replaced by 1 over 4 positive square root of 15. Okay, let me do it. So 4 positive square root of 15 whole to the x power equals to 1 over 4 positive square root of 15 the whole square. So here I replace this 4 negative square root of 15 by 1 over 4 positive square root of 15. So since we have square for this stuff, the same square is taken over here. Okay, now 4 positive square root of 15 whole to the x power equals to, here we have exponent 2 for the fraction over here. So whenever we have an exponent for a fraction, the exponent can be taken separately for numerator and denominator. Then I'm getting 1 square over 4 positive square root of 15 the whole square. Okay, 4 positive square root of 15 whole to the x power equals to, so the evaluation of 1 square is just 1 over 4 positive square root of 15 the whole square. Okay, now 4 positive square root of 15 whole to the x power equals to, okay, now if I move this 4 positive square root of 15 whole square to numerator, it will be multiplied by 1. And also whenever I move a particular term from numerator to denominator or denominator to numerator, have to change the sign of the exponent. So here already we have a positive 2 as exponent over here. So when I move this term to numerator, the exponent positive 2 will become negative 2. So then I'm getting 4 positive square root of 15 whole to the power of negative 2. So here the two terms are equal with the same base. So the base on the left side is 4 positive square root of 15. On the right side also we have the same base, 4 positive square root of 15. So whenever two terms are equal with the same base, we can equate the exponents. So then we get x equals to negative 2. So now I have solved the second equation. I got x equals to negative 2. Already I have solved the first equation. I got x equals to 2. So now I got two values for x in the given equation. One is 2 and the other one is negative 2.